Oh, hello everyone. Today our topic will be deep learning. Different aspects of deep learning for machine vision. We're skipping to our first presentation, which will be from Euresys, from Marc Damhaut. So Marc, I think it would be great. Yes, I see you're starting. It's perfect. Only thing I cannot see at the moment is, now I see you, Marc. Okay, and the presentation. Everything is fine. Please go ahead.
Okay, thank you very much, Peter, for the introduction. I'm going to try to convince all of you who want to start using deep learning to test our Open eVision deep learning tool. So I'm Marc from Euresys, and today I'm going to talk about our Open eVision image analysis and libraries. So contrary maybe to many of the deep learning products that are on the market, at Euresys we sell components only. We sell software components under the form of libraries that our customers can link to their application. They can include these libraries into their application to make a system, to make a machine. So the Open eVision libraries are hardware-independent libraries for machine vision inspection applications. They are just libraries, so you can do whatever you want with them, but we really focus on machine vision inspection application. They are compatible with any kind of image source, so it can be images coming from frame grabbers, GigiVision, USB 3 vision cameras. They are compatible with Windows and Linux, currently only Intel chips. And we are moving towards ARM, and with the deep learning libraries, we are compatible with different kinds of GPUs also. We have 17 libraries in Open eVision. We talk about inspection here, so we can do inspection with 3D. We have a color inspection, blob analysis, localization, a subpixel measurement. We can read characters, we can read codes. And today we are going to talk about the 3 libraries that can do deep learning inspection. They are EasyClassify, EasySegment, and EasyLocate. I have already talked about these libraries in previous webinars, so I will start with a short recap of what we can do with these libraries. And for the rest of the presentation, I will mostly focus on a demonstration and mostly focus on what is new, what we have added as a capability compared to last year. So the first of the 3 libraries is called EasyClassify. And the application case, the use case of EasyClassify is object detection and classification, obviously. But with EasyClassify, we can detect the defects on a single object in the image. So EasyClassify works on the entire image at once, and during production, it associates a label to the entire image. So the label could be, for example, product number 1, product number 2, if you want to recognize different products, or it could be defect number 1, 2, 3, or 4, if you are interested in a defect inspection. EasySegment is much more precise. Instead of just returning a label, EasySegment returns a segmentation mask. What is the segmentation mask? It's a mask which tells pixel by pixel in the image to which class that pixel belongs. In the unsupervised mode, we train only with good images. So we train the network only with the image of good objects without defects, which is quite easy to use. Of course, obviously, in this mode, the system can only recognize a single type of defect. And so this is what it will be doing in unsupervised mode. In supervised mode, now we train the neural network with annotated images. These are images where we have highlighted, you see the part in yellow here, we have highlighted defects and we have assigned a class to each of the defects. In this mode, the library will be used to locate the defects in the image and to classify the different types of defects. Last but not least, EasyLocate is able to return labeled bounding boxes for each of the objects it finds in the image. Bounding box means that we can locate the objects in the image, so we have a coordinate, and the label tells us which kind of object we have in this bounding box. So it is used for classification and localization of objects or defects in the image. It's even precise enough, for example, to count the number of instances of objects that you have in the image. The Open eVision Deep Learning Studio will be the application that you are going to use now for my demonstration. That's also the application that I will try to convince you to use. I don't remember the percentage, but a number of you today are interested in deep learning solutions. So I will try to convince you to go to our website, download Open eVision Studio. It's free of charge and it does not require any license. And it will allow you to test our deep learning tools on your own images. So that's what I'm going to do now. Let me switch to the Deep Learning Studio. That's it. When you start the studio, that's what you will see. The first window is not interesting here. It just tells me that I do not have a GPU. So when there is one, it tries to detect an NVIDIA CUDA GPU here to accelerate both the training and the inference. I'm just making this demonstration of on a simple laptop here, so I do not have a GPU. And what do I see here? The window that allows me to create a new project, open an existing project, or open one of the recent projects I have worked with. I have prepared this presentation today with this stone tile project, which is a set of images of small ceramic tiles with defects. And that's the one that I'm going to use for this demonstration. So I just click OK, and then it loads all the images in the data set. We see that we have 605 images that have been classified already into good images. Then we have images with some traces of glue on the tile, which have tiles that have been damaged, or most obvious one here, a set of broken tiles. You can see that in this tab here, the dataset and annotation tab, we can choose for each of the image to which class it belongs. And in your case, so imagine that you want to use the studio on your own images. What you would do is just add your images using this button here, and then assign a class to each of the images of your data set. While we talk about the data set, then we have to go to the second tab here, which allows us to control the data set splits. And so what is a data set split, and why is it so important? A data set split is a division of our data set into different groups. And the data set is just the set of images. So a data set is the group of images that we have. Our data set is in deep learning split into three types of images, three types of set. We have the training set, we have the validation set, and we have the test set. The training set, so the training images, will be used to train the neural network. What does that mean? We can see this here. The training set, the training images will actually be used to update the model. They will be fed to the neural network during the training. This training process is an iterative process, so it's a loop, and we can choose actually how many times we run the loop, how many times. And during this training, for every loop, we are going to validate the result of the training against the second set of images, which is called the validation set. For each loop, we are going to measure metrics and try to evaluate, is this iteration of the neural network good or bad? Is it getting better or not? And this will be done using the validation set. At the end of the entire process, when we had reached the maximum number of loops and we are happy, we keep the best network, then we are going to do a final test using the test set, using the test images, and it will provide a final set of metrics that will be a very good evaluation of the performance of the network in production. You can ask me, yeah, it's good, but I already don't have a lot of images. Why do I already have to split them into different sets? Actually, it's really, really important. Don't use 100% of your images in the training set. If you do that, the model can simply learn to recognize the images in the training data set and not really the underlying features that you want to detect, not really the defects that you want to detect. So we really recommend to use that system with the training, the validation, and the test set. And the test set in itself is also very important because the test images are not used during the training. So the training and the validation images are used during the training, but the test images are not. So they will provide metrics independent of the training data. And it's really the best way to check the expected performance of the model in production, because in production, of course, you are going to use the neural network with brand new images. So in this dataset split tab of the Open eVision Deep Learning Studio, you can control what's the proportion of images. That's what we have here that goes into the training, validation, and test images. So by default, 70% of the images go to the training set, 20% go to the validation set, and 11% of the images go into, 10% go into the test images. Here is just a rounding difference. So I'm going to show you this in the application. One more thing, though, we have added recently a manual control of the split. And what is it for? By default, all the images are chosen randomly, and they go into the training, validation, or test split randomly. So you see the number of images in each split here. But we have seen some use case where we want to provide more control over the choice of images to the customers. The first one is when you have a small number of images. Then in this case, you can use your knowledge of the problem to put representative images in each set. And if you really don't have a lot of image of defects, for example, you want to make sure that every defect is represented by a good number of images in the training set. Another use case is to continue a training with new images. So in this case, you need to manually select and move the new images that you want to add into the training set. So all this is possible inside the Deep Learning Studio. We have it here, data set split. You see all the images here. We have a split here that has been created already. It has been used for training already, so that's why it's locked. The small lock here means that I cannot change it, but it does not matter. I'm going to create a new one. I keep the default proportion, and in the new one, I can choose where image goes where. Here, I just have to right-click them and transfer the images to the correct set if I want to do so. The next tab is the data augmentation tab. We didn't add any new feature here, except the fact that you can now create different sets of data augmentation parameters. It's for testing, really useful. And then we reach the tool set, and the tool set is the most important one. That's the one that we are going to use to train the network. In the tool set, something new now, when we load a tool, then you can see the result of any previous training. So this one has been trained for 100 iterations. So it's finished already. I'm going just to show you to add a new tool here, which has not been trained yet. I can create a new split for that tool and choose, for example, a data augmentation and then start the training. And then you see that the training is starting. So that's what you will have to be to train the network on your own images. It's important to note here that I can continue to work. And for example, if I want to work with another tool, I can create yet another one here. For example, this one, I would like to try a larger network and see the result. I again create a new split and I start the training on this one also. This one was with no data augmentation. You see that this one, the training has started, actually not really. The training has been queued, and we now have a queue where we can queue different training requests with different parameters for different tools. And so it's really, really interesting for testing, because you are going to be able to queue different trainings, for example, on in the evening, and then when you come back in the morning, all have been trained and you can analyze the results. Let me stop this one and this one, and I continue with the next tab. Once the training is done, and I go back to my first tool that has been fully trained, you see the results, the confusion matrix here. You can, for example, check whether everything went well by selecting only the test set, and that's the result. And we see that it has detected 14 broken images in the test set with all the results that you can measure here. Last tab is the inference test. It's used to add new images and just tell them independent, test them independent of any tool. I'm going to go back to the images on my disk. Don't tag, just pick any one, and I can run the tool number 1 here on this image, and then I can see that it has detected in 337 milliseconds that 99% chance that this is a broken tile. Everything is okay. So this is what we can do with the Deep Learning Studio application. New features, new project, new dataset split control, training queue, and more features. One last thing I would like to tell you before the end of the presentation is that at the same time we have improved the classifiers, we have improved the performance of our classifier, and the most important improvement has been that we now provide classifiers with a pre-training. Pre-trained classifiers have been initialized with the results of a training on a very large and complex data set of several million images. So you will ask me, what's the point? Because they are not my images. So why do you start training with images of someone else? Actually, we see that pre-training allows to transfer the knowledge of some of the universal features, such as edge, corners, learned on a big data set to a smaller data set. So pre-training will not help if you already have a very big data set, but it will possibly provide much better accuracy if you have a small data set because of the pre-training. It also allows for a faster training. So it's really something that has proved really useful in a lot of application cases. So please go to our website, download Area, you go to Open eVision, and you see the links here to the setup file of Deep Learning Studio, the additional resources, a lot of images. I don't have time to show you more, but we have videos on our YouTube channel that explain how to use deep learning. We have translated these videos to a lot of languages also. And we have a set of support engineers all over the world who are ready to help you with your application case. Thank you.
So, thanks a lot, Marc. We already have a question. And the question is, could you once again explain the difference between training, validation, and test?
So the validation, the validation images are used during training. Training is an iterative process. If I go back to the deep learning application validation in results, and we will see sorry, the tools, we will see here the iteration. So you see the matrix. In this one, we have proceeded with 100 trainings, and every training improves the network. So the validation images are used during this process. The test images are used at the very end, only one time, to evaluate the final neural network.
Another question is if someone can use a model created in TensorFlow.
No, here this is, I would say, a tool that has been developed by Euresys. So this is our own network, and the format of the files and everything is particular to Euresys. So the only way you can teach the network is by providing images.
And does your solution supports ONNX model?
I don't think so, but I'm not too sure what it is. But again, this is a tool that has been, which is particular to Euresys. So I have not heard of the fact that we could be able to load that kind of model.
I think you will be able to answer this question afterwards. I see the name of the guy, and Mark, you will send him an email.
We'll get back to you. Thank you.
Okay. Once again, we have time for one last question before we're going to the next presentation. And yeah, what kind of license do you offer for eVision deep learning?
The licensing is pretty simple, actually. We don't have any development license, so we sell a single runtime license for the 3 libraries: EasyClassify, EasySegment, and EasyLocate. And this is a price that just depends on the quantity of license that you want to purchase. So the licensing is pretty simple.
So thanks, Mark. Maybe you can close your presentation.
Yes.
So Jarek has the chance to get all the... Thanks a lot, Mark.
Thank you.
Mark will be there for our final Q&A session at the end. Question for you: how can I obtain metrics or statistics on my images in the inference test lab tab?
The inference test tab is meant to test single images, so there's no statistics or there's no metrics. If you need more information and metrics about the test, then please move these images into the test data set, and then there you will get the full set of statistics.
And how many images do I need in my data set to get a good classifier with a new pre-training option?
Every time we get this question, how many images? Yeah, that's one important point for the deep learning. I already answered. I mean, it really depends on the application, and we have application where we say we need thousands of images. Some applications just less than 100 will do. What I would like to tell here, because this is really new, is that with the new pre-training option, then we can get better results with small data sets. So if you have tested our tool last year and then you more or less were disappointed because you don't have enough images, then please test again with the pre-trained classifier. It's also because we have more experience now in deep learning with real customers and real applications. And what we see that a major cause of failure is a bad, wrong, or ambiguous annotations. So it's always best to train with fewer images that are well annotated than with a lot of images that are badly annotated. And this is really our experience.